AI agents are all the rage right now, but a paper that just came out talks to some of the general security questions and vulnerabilities that come with this new tech. Let's face it, agents are a blast to play with, but they don't come with all them enterprise features Tommy from your DevSecOps team is going to love and ask you for while it's going through the procurement process. The paper we'll break down today is a bit of a hybrid to kick things off because it consolidates all the papers on agent security vulnerabilities into one unified view. We are going to highlight all the key points in the paper and then take a bit of a deep dive into my favorite section about indirect prompt injections on AI agents. This is not to be confused with your typical prompt injection, but I'm getting ahead of myself now. Let's jump into this paper. And before we start, for anyone that is not quite sure what an AI agent is, Anthropic released a blog post recently titled Building Effective Agents. And in that, they say, and I quote, agents are designed to reason about states, actions, and outcomes in a robust, interpretable, and safe manner. The way I like to think about good old AI agents is that it is AI that can actually do stuff, like send emails on your behalf or look at what meetings are on your calendar for the day and cancel them. They interact with the outside world using something that we call tools. From the paper we're going to be breaking down, AI agents have revolutionized various fields from healthcare to finance, customer service, and even agent operating systems. These intelligent entities can autonomously perform tasks, make decisions, and interact with their environment based on predefined objectives and data inputs. This is different than your normal back and forth interaction with a chatbot because of the AI agent's ability to break out of the chat and do things, accomplish tasks, if you will. Agents are also different than traditional RPA systems because the workflow is fluid and agents can adapt if there is one step that fails, or it can plan and execute things that are a bit more fuzzy. In the paper, they talk about 4 critical knowledge gaps. It starts off strong by highlighting these knowledge gaps that lead to security challenges with AI agents. These 4 gaps are the unpredictability of multi-step user inputs, the complexity in internal executions, the variability of operational environments, interactions with untrusted external entities. Let's explore each one of these in detail. Gap number 1, the unpredictability of multi-step user inputs. This is the user interacting directly with the LLM and being a bit nefarious. The challenge here is that users interact with AI agents throughout the task execution process, providing multi-turn feedback, and this diversity of inputs can lead to security threats, especially when user instructions are inadequately described. The risk is that there is insufficient specification of user input, and that can affect not only the task outcome, but it may also trigger a cascade of unintended reactions with potentially severe consequences. 2 ways that this plays out in practice are jailbreaking and prompt injection. And a little side note, while the 2 terms are often used synonymously, prompt injection and jailbreaking are actually different techniques. Prompt injection disguise malicious instructions as benign input, while jailbreaking makes an LLM ignore its safeguards. For a jailbreak attack, users manipulate the AI agent to bypass its ethical constraints, For example, a user might trick an AI assistant into providing instructions for illegal activities by framing the request as a fictional scenario. Prompt injection, on the other hand, is where an attacker might ask an AI agent to ignore previous instructions and instead do dot dot dot, where dot 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 is the harmful command. Now let's get into gap number 2 that they identified in the paper, the complexity in internal executions. The challenge here is the internal execution state of an AI agent is a complex chain loop structure ranging from prompt reformatting to the LLMs planning and executing tasks, or even using external tools, as we talked about. The risk is many of these internal execution states are implicit, making it difficult to observe detailed internal states. And this leads to the threat that many security issues cannot be detected in a timely manner. So how does this play out? Well, with hallucinations and misalignment. Let's not be mistaken. I enjoy hallucinating just as much as the next guy. But the tricky part about LLM hallucinations in agentic systems is hallucinated output makes us not trust the agents, and that is no way to see widespread adoption. As complex systems are built on the output of one agent, if it is wrong, it can make the whole thing come crashing down, and the errors propagate. This isn't a security vulnerability per se, but what happens when you ask an agent to share that confidential report with your colleague Jane Smith in marketing, but you forgot to give the agent Jane's email in your prompt? The agent then hallucinates an email for another Jane, and it ends up being Jane Doe in HR, and then the agent sends it. Oof! Hopefully, there wasn't anything important in that confidential report. It's worth noting, hallucinations are such a common problem in the AI world. There is a ton of research being done to counterbalance made-up output. One of the ways is by using multi-agent architectures to have different angles and agents fact-check the output of one another or critique the output. The other way that I mentioned this can manifest is through misalignment. Misalignment is when the AI agent's actions may not align with the user's intentions due to misinterpretation of complex instructions. For instance, an AI tasked with optimizing a company's profit might suggest unethical cost-cutting measures because they've been following Elon Musk on Twitter too much. Or, in other words, this agent did not understand the assignment.
You understood the assignment. You understood the assignment.
Gap 3 is the variability of operational environments. The challenge here is that AI agents often operate across various environments during development, deployment, and execution phases. The risk is the variability of these environments can lead to inconsistent behavioral outcomes. For example, an agent tasked with executing code could run it on a remote server and have the keys to the castle, potentially leading to dangerous operations. One way that this can play out is through a sandbox escape. This is where an AI agent designed to operate in a controlled environment might exploit vulnerabilities to access restricted system resources. For example, an agent meant to analyze data might attempt to access sensitive files outside of its designated sandbox. Another problem with variable operational environments is inconsistent behavior. An AI agent might perform differently when moved from a testing environment to a production environment, potentially leading to unexpected and dangerous actions. Finally, let's talk about gap number 4, interactions with untrusted external entities. The challenge here is AI agents are designed to use tools and interact with other agents, but current interaction processes often assume trusted external entities. I think we all know the internet can be a dark and scary place sometimes. The risk here is this assumption leads to a wide range of practical attack surfaces, such as indirect prompt injection attacks. But wait, what is that, you ask? Indirect prompt injection attack is a form of attack where malicious users strategically inject instruction text into information retrieved by AI agents' web pages and other data sources. This injected text is often returned to the AI agent as an internal prompt, triggering erroneous behavior and thereby enabling remote influence over other users' systems. For example, web data retrieved by AI agents using web plugins could be misinterpreted as user instructions, resulting in the extraction of historical conversations, insertion of phishing links, theft of GitHub code, or transmission of sensitive information to attackers. One of the primary reasons for the successful exploitation of indirect prompt injection on AI agents is the inability of AI agents themselves to differentiate between valid and invalid system instructions from external resources. In other words, the integration of AI agents and external resources further blurs the distinction between data and instructions. So, this can be triggered unintentionally by users who mean no harm whatsoever. But it's not all bad news. To defend against indirect prompt attacks, developers can impose explicit constraints on the interaction between AI agents and external resources to prevent AI agents from executing external malicious data. For example, you can augment AI agents with user input references by comparing the original user input and current prompts and incorporating self-reminder functionalities. When user input is first entered, agents are reminded of their original user input references, thus distinguishing between external data and user input. To reduce the success rate of indirect prompt injection attacks, several techniques can be employed. These include enhancing AI agents' ability to recognize external input sources through data marking, encoding, and distinguishing between secure and insecure token blocks. Let's talk about the implications for software engineers, aka you. If you ever want to get your agent into production and you want to appease good old Tommy from the DevSec team, as we build with AI agents, let's make sure we design flexible AI agent ecosystems that can adapt to variable user input while maintaining robust security measures. 2, develop methods to audit the complex internal executions of AI agents. 3, ensure consistent and secure task completion across multiple environments. And 4, implement safeguards for AI agent interactions with potentially untrusted external entities. As we mentioned, in contrast to conventional LLMs that directly produce final outputs, agents accomplish tasks through executing multi-step intermediate processes and optionally interacting with the environment to gather external context prior to output generation. This expands the input space of AI agents, and it has its pros and cons. I'm not going to lie. You have more possibilities to accomplish great things, but it also offers attackers more diverse attack vectors, such as the ability to manipulate any stage of the agent's intermediate reasoning process. While AI agents offer tremendous potential, it's clear that we got to take care of these security challenges to be enterprise ready. It's also worth noting, if you made it this far, you will probably like what we're doing at arcade.dev with our agent authentication and secure tool calling platform, bringing the enterprise features you need into your agent building workflow with ease. And it works with all the tools you know and love, like LangGraph, CrewAI, Anthropic, OpenAI, just to name a few. Check out the link in the description to learn more. And until next time, stay safe out there.